Well, hi, Mathletes. It's Tutor Grant. Thanks for showing up for your learning. We didn't quite get to this question in our intermediate equations practice, and I made the saucy mistake of saying, I know how to solve this problem. So I promised I would show you. Okay, so we're going to want to figure out how to make an equation out of this, and that's going to start with some let statements. Okay, so these would be the let statements that I would use. I would say let t equal the number of minutes past 2 p.m. Okay, so we're going to think about this problem in terms of minutes past 2 p.m. That way we can figure out how to approach that question. Okay, we need this is our variable, time, t. Now we can create two more let statements that have to do with the position of the hour hand and the minute hand. That way we can algebraify those two quantities and proceed. So we're going to say let m equal the position of the minute hand in degrees, and let h equal the position all right, so now we need to create some equations. The equation for m is rather simple. Okay, m is going to be equal to some function of t. As a minute goes by, how many degrees go by? Well, there's 60 minutes here, but 360 degrees. So every minute it's going to advance 6 degrees. There is our formula for m. It's nice and easy. Okay, but t is a little trickier. Okay, sorry, for h. H is a little trickier. So h is equal to, well, first of all, we're starting 60 degrees turned. So we're 60 degrees plus some variable of some amount of t. Well, in 60 minutes, we are going to travel from here to here. That's 30 degrees, okay? 30 degrees between 2 and 3. So in 60 minutes, it travels 30 degrees. So it's not hard to show that for every minute that passes, we move 1/2 of a degree. So there are our equations. Now, we want to find when the minute hand is going to be down there, somewhere about, and this one will have moved ever so slightly there, so that this is still 60 degrees, right? That's situation one. That's one of the times where this will be. I'm not sure if that's a 60-degree angle or that's a 300-degree angle, to be honest, because we were starting from the minute hand here and going to the hour hand. It seems different to start from the hour hand and go to the minute hand. But we're going to find it anyway, and then we're going to tell the marker, hey, I found this one. I'm not sure if it's the one you're looking for, so I'll find you the second one as well. Okay? Because your question was ambiguous, sir. Okay, so let's go. All right, so now what do we know? We know that the position of the minute hand will be equal to the position of the hour hand plus an extra 60 degrees. Okay? Because at this time, right, if we look at it, the hour hand will be here and the minute hand will be 60 degrees ahead of that. So if you took the hour hand position and added 60, you'd get the minute hand position. There's our equation. Put in your values of t, that one and this one, and just solve this. Okay, so we got 6t is equal to h, which is 60 plus t on 2 plus an extra 60. So let's subtract t on 2 from both sides. That will give us 11 on 2t is equal to 120. And I don't know how you solve an equation like that, but this is the way I teach you to solve it, which is to multiply by the flip fraction. That to me is the easiest method. And then we get cancel, 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 cancel. We have isolated t. That's how many minutes need to pass for this situation to occur. So t will equal 240 on 11. 240 is very interesting. I happen to know that 242 is equal to 22 times 11, and this is just less than that. So this is equal to, if I write it as a mixed number, forgive me if you don't like mixed numbers, but that's 21 and 9/11. That's how many minutes need to go by so that we achieve this situation. Okay, so we would say, so we would sum that up by saying, therefore, the hour hand will be 60 degrees behind the minute hand in 21 minutes and 21 and, we should say 21 and 9/11 minutes. There. What is 9/11 in seconds? Multiply 9/11 by 60 and figure it out, but I don't care to. This is exact, and any decimal representation is going to make me want to barf. But there's another thing they might be looking for. Maybe this doesn't get full marks because to them that's a 300-degree angle. It's not a 60-degree angle because they want to measure from minute hand to hour hand. Okay? So if you can imagine, this other situation is going to happen when the minute hand is somewhere around here and the hour hand is somewhere around there. Okay? And this is still 60 degrees. Okay? So let's see how we would set that up. All right? There, if you did minutes plus 60, you would get the position of the hour hand. Right? Because this is, here's the minute hand, and then I add 60 degrees, I get the new position of the hour hand. Let's sub in and see what happens. I happen to know it's bad news. Watch. So we have 6t plus 60, that's m, is equal to 60 plus t on 2. Uh-oh. If you see it already, good for you. We're going to subtract 60 from both sides. Uh-oh. You see it yet? 6t is equal to t on 2. When is that true? Okay, well, I don't know. Well, if you know the thing, do you know what value t that makes that true? Okay, minus t to t on 2 from both sides, and you'll see it. Okay, then this is what you'll get. You'll get 11 on 2t equals 0, and t equals 0. Oh no! That's not the next time. That's where they started. How are we going to distinguish that? Well, what if you add 360 degrees? Okay? Because think about it. This minute hand goes around 360, and then we go down here. Okay? So, from that point of view, now we want hour hand plus 300 to catch up with that one. So we're actually, instead of doing plus 60 over here, allow me to just like do this again correctly over there, and this time purple, we will have the position of the minute hand there is equal to the hour hand plus 300. That's what we need. That's how we need to set that up. And then we substitute in our 6t is equal to 60 plus t on 2 plus 300. Cool, eh? And then we're going to, subtract our t on 2 from both sides. We still have 11 on 2t is equal to 360. And then you multiply by the flipped fraction, 2 over 11. So we multiply this by 2 on 11. And then we get that time is equal to 720 on 11. Okay, still on 11 here. That's very cool, isn't it? This is neat that that factor 11 appears, which is nowhere on the clock. But it's all over these types of problems. Okay, so what is 720 on 11? Well, how do we get a number that's close to 720? So I can write this as a mixed number. Well, I happen to know that 660 plus 55 is pretty darn close to 720. And that's the same thing as 60 multiplied by 11. There's the extra hour. Plus 5 times 11. There's the 5 minutes. Okay, the 5 minutes meaning like we went all the way around, rocking around the clock, right? Then we got to go 5 minutes to catch up with the hour hand that was now at 3, but as we catch up, it still moves a little more. How much does it move? We're going to see the remainder here. So this is the same thing as 660 plus 55 is equal to 715. So this is equal to 715 plus 5 on 11, which is the same thing as saying t is equal to 65. 65 plus 5/11. So the next time, I've run out of space, but I'll write it down here. Therefore, the minute hand will be 60 degrees behind the hour hand. Notice that that's flipped from the other situation. Will be 5 minutes and 5/11 after 3 p.m. There. There's a situation. That's how I would solve both. Algebra. There's no way I can do any of that in my head, or just know. I mean, you just have to algebraify it, find a way to express the position of the arms of the clocks in terms of degrees, and then set things equal to each other and calculate. It's very algebra. The trick is setting up the algebra correctly and having the insight to put it into algebra. Although, as I was saying, this was the equations lesson. So that's the big hint that algebra works. All right, everyone. I hope that's helpful. I hope that it allows you to solve some of the questions in the homework and solve questions like this when you take the JMO or the IMO or the challenging math Olympiad type situation. Bye for now, everyone. See you in class.